when you go to a teller machine or go something, you'll get a so-called pending transactions, right? So they collect all these pending transactions. When all these things close down, then they run the batch to make sure it's consistent. Then essentially you say, okay, so basically what architecture are we going to use? Then you can say, what are the details in the flow? Basically, what exactly is data flowing through our system, right? So this is very similar to our approach in object-oriented approach, just like there in object-oriented approach, we use objects and classes to keep our information, and also associate the method operating on these data with the data. That's the only difference, guys. Object-oriented approach. Fundamentally, because if you say your fundamental carrier of the information, your ingredient, your building block, are your classes, then you are in the object-oriented category. If you say, I'm actually worry about data and the functions separately, you are in a more traditional approach of data flow. Okay? See the difference between object-oriented approach and traditional approach? Just that. Okay? One is, once we start writing down information, we're defining classes. All right, your object-oriented approach. You basically say here the data and operation around it, we associate them together. All we do in use cases, in sequence diagram and all these class diagram and state machine, all to determine the data we put in one class and operation we put in one class. Okay? Here in traditional approach, we don't worry about action yet. Okay? That will be later. Now let's write down all the data, put them together in our header files, in our databases, tables. Here you are not associating your data with the operation. You're identifying the data first because you are a data flow driven approach. That's the key difference. The key difference between your object-oriented approach and your traditional data-driven approach. Okay? You don't worry about the actions until later. Not associating data with the action. That's more traditional approach. But I mean, your programming language in C doesn't even support that. But in C++, yes, you're defining classes, you have data and their action together. Okay? Once you have data, then you can say create your data dictionary. This is essentially your header file in C programs, right? Then you define the logic of the process. You are talking about actions now. You still need to do actions and data, right? Because that's something you cannot escape. In computer, you're processing your data with actions. Just that you don't have a mechanism to actually associate your data and actions together in a package, which called class. Now they are actually separate into header files and .c files. Okay, separate. So in that decision process, in the logical process, basically you're determining branching and your jumps, loops, switches, that kind of thing, right? Essentially your algorithm. Then you really get down to, I mean, how you get the data store information, how you store on data in the file. Then pretty much you got your database, right? Whether you have database or not, that's up to you. Or you can use a linked list, or you can use a stack. Either way, it would work. Then you also have to deal with input-output specification, which we treat as part of our class as well, right? We have input class, interface classes, basically boundary classes for us to capture all these input-output relationships. Basically, you can see all the things we need to do in object-oriented approach, how to do here. Actually, the other way around, because we are doing this first. We're doing this first. Everything we have been doing here, we need to do the same in the we need to do them in object-oriented approach. just that we are doing them differently. In the object-oriented approach, we are class and object centric. Everything is a class. Everything actually is an object of a class, right? A class is the data and the operation associated together, right? Here, you can see that there are no such strong association with data and operation. They are quality associated together because your action will happen on the data, but they are not enforced on your compiler level, on your programming language level. That's the difference. Your design level. Okay? They could be related, but yeah, they're related more in the running code level, not on the concept level. All right? The size, so essentially the how much memory you have and that kind of thing. Hardware requirement, what kind of system you're using. So essentially, this is just a step, recipe, right? Step by step. Survey. We will go through. If you fill out all the survey form, then you got the answer. Okay. Again, here we're not talking about you come out with the best, most optimized design. You're going to, if you follow this, you're going to come out with a pretty generic and lousy design. Okay? Because you are not considering all these optimizations. People have come up with databases, people have come up with graphics, people come up with natural language processing in ML, in the architecture or operating system. No. You're basically treating this as, okay, it's basically a data flow machine, data flow graph. Then, if you have this program already, this solution already, then you can look at it and say, aha, what I learned in database and help me here. I'm not going to use my stupid tree implementation to store data because that will be way too slow. Okay? I'm actually going to use a database to store my data. Okay? I'm not going to use my sequential search of the linked list for my search functionality. May actually use a hash table. Right? So these are the optimization you can do to make your program better and better. But here, by following this fundamental 9 steps, you're coming to one solution. Just like following our basic object-oriented approach, you're coming up with one solution. Okay? That's why we are talking about elements of software engineering. Basically, are the steps you follow to come to one solution. To regulate your thinking process, so you are not just jumping around and start randomly programming, and hopefully it will work. Okay? You are actually trying to regulate your development process. You think these things through, then you'll do your program. That's it. Okay? Either you use the data flow as your fundamental knowledge representation, then you're following this approach. Or you are using object-oriented concept, like classes and objects, as your carrier of information. Either way, you have to cover all the information in the system. You basically follow one approach or the other to come to a solution. Okay? Later on, when you learn all these optimization in different classes, you can say, oh, I don't even need to think about using a tree or using a linked list. I know it's going to be a hash table. Right? I don't even need to know what exactly is that network programming. I'm just going to use a client-server architecture based on socket. Do I need to know what is going on with TCP/IP? No, I don't. That's not my problem. That's why now we can have so many Java programmers who have no idea of how network actually works. Yeah, because we are putting in all these level of optimization and abstraction to make you work better and faster. Can you still implement the same TCP/IP stack with in C? Oh yeah. But if you go re-implement that, number one, it's going to be fairly slow, right? If you actually go to your C to implement your TCP/IP stack, then use that stack for my project. I'm not sure you can finish my project within the 8 weeks. Okay, and also your program tends to be very buggy. That's why you want to use somebody else. I mean, already proven libraries, so that you don't have to deal with all these bugs yourself, right? So your program can be more robust. So this is so-called separation of concern. If things have been taken care of by other people, let them take care of that. And you just worry about the new things, the absolutely new things your system has to do, right? Now to go re-implement this interface, now to go re-implement the network stack, not even to implement the whole Java virtual machine and the application framework your Eclipse generating for you. That's not your job. Your job is to add the classes you need and get them implemented to process your data. Okay? So here, you can see that our basic approach here is to come up with one solution to address our problem. We are not thinking about come up with the best solution possible. We are looking at come up with one solution. Okay? And later on, you have plenty of opportunity to optimize. But for our class, we want you to be able to finish a project. Okay? Then you have plenty of, the most common thing we see is people say, oh, I'm just going to start a program. Then at the end of the term, nothing yield. Nothing yield. They will come to me and show me like 50,000 line of jump code, and nothing works. Okay? This thing, if you follow our approach like this, you may write 1,000 line of crappy code, but hey, all your functionality are there. Then you can say, oh, I don't like it. Okay, now you can go optimize it. Okay, now say you have written 50,000 line of code and come to me and I have no feature implemented. Okay, software engineering is boring. Writing code randomly is fun, right? But software engineering is really boring. Software engineering is really about get the job done. Okay, you do better, you got paid more. You do not as good, you got paid less, right? But it's not about you just go home and write random code and say, oh, I'll try this out, I'll try that out. I tried 100 frameworks, but hey, I don't know, I can't really get my project finished. Okay? Software engineering is a boring process to get it done. That's why all these companies give you free food, free lunch, free sugary drink, and give you massage and all these nice things. Why? Because it's a boring process. They need to get a job done. What they're doing all along is to get you excited and in high spirit to get the boring job done. Okay? Otherwise, it will be burned out pretty quickly. I mean, your job is to actually map specification into code. I mean, if it's not being because of this paid so well, I think most of you guys won't be here, right? So, hey, writing code is very interesting, but getting those tedious specification implemented, man, this is really a grueling process because you actually have to worry about all the details. Think about it. In laboratory, it's so excited to get that software implemented to control the Boeing aircraft. Oh, nice, great, I mean, everything. But now it's come to, okay, so make sure that it never will fail in all kinds of situations. That's a very boring process. That's a very boring process. But you have to get it done. Otherwise, the thing will not be correct. Again, for us, the first step is to come up with one solution. Then you can deliver the solution. Then you will have time to iterate over the solution. If you never deliver a solution, you will never be able to iterate over a solution to get a final solution. Okay? Programming and software engineering on this level is a fundamental thing you do as a software engineer. All other classes, ML, artificial intelligence, database, system programming, parallel programming, and all these things are teaching you how to create a better system. However, if you don't even have the skill go from 0 to 1, from 0 system to 1 working system, no matter how many optimization you apply to the 0, it's always a 0. Okay, that's the core. So that exactly is why we set this to be 300, basically for you to learn the basic approach. Okay? All right, so enough of that. Let's see what we will do today for our quiz. Actually, this is the second half of our term. We are reading the stake a little bit. I'll give you guys a harder and harder problem. Today, we'll look at the problem of convert a sorted list to binary search tree. Okay. All right. So you have so essentially. Okay, I think I have a. So I'm actually copy this from an online test website. Okay. No. That refuse connect. Okay. What is the well do? That's okay. I probably have to jump out of D12. Okay, this is a legitimate question, okay? Let's see. Okay, maybe they already closed down all these questions, which I don't know. Maybe not.
I didn't expect you to sign in.
Maybe. We'll see. Not really. You here? Hopefully. Okay. You already see. This is our question. This is a legitimate question. Okay. Not something that you actually company using this, but who knows who are using this, right? Okay. So too small. Right, so we are basically raise the stake a little bit. Given an array where the elements are sorted in ascending order, converting it to a high balanced BST, basic balanced search tree. For this problem, a high balanced tree is defined as a binary tree in which the depth of the two subtrees of every node never differ by 1. Okay? Given this array, so you can sort it from -10, -3, 0, and 5. If you input that in your constructor, it's going to give you this search tree. Okay? This is one of the search tree. So yeah, it's actually fairly balanced. You have two branches, not differed by 1, right? So here basically you are trying to come up with a constructor based on array input. Okay? I don't actually, since we just get started, I don't expect you to finish this in the 20 minutes we have left. But just to get you started, okay? This is actually, we are jumping out of your comfort zone of writing one of the method or two of the method in learning data structure, right? We're low-level algorithm class. So how to figure out the depth, how to search binary search, depth for search or breadth for search, okay? BFS, DFS, and this is actually we are trying to come up with. This is actually a pretty good, I would say, good balanced problem. It's a little bit, I would say, a little bit harder for you guys. I would say, although it's more, don't be fooled by this. This is easy, but for me, I actually need to code spend some time with this to get it right. Right? If I don't know the answer, which I already know, so it's unfair, right? But for you guys, it's actually a good challenge. Okay, a good challenge. This will also give you a taste of the format. You will be able to see you can write the code into this this coding box. Okay, this coding box is actually a compiler plus execution environment. So if you write your code into this, you can submit. It will compile your code, run your code, and apply test cases. And now share with you to it and tell you how you do. Okay, pretty much all the online test environment you will see in your online coding interview will be like this. Okay, so getting used to this would be fairly nice. You can see that although, so this is about half of the time when people submit a solution, it is correct. Half of the time, 50%. All right, I'll let you guys to work on this. I would highly recommend if you couldn't finish in class, go back home and finish it today as our homework.